All right, guys, so let's keep going. Last time we talked about rectangular coordinates, how to plot ordered pairs. Let's actually talk about functions and equations now. I know you're thrilled. If I could find it. All right, where'd you go? All right. So a solution, right? We know what equations are. A solution to an equation of two variables is the ordered pair xy that makes the equation a true statement. So what do I mean by that? Well, let's see. Decide if the ordered pair is a solution to the given linear equation. So we have y equals 5x plus 8. Now remember that x is first and y is second. So when I look at this, what I'm really asking is this. Is y actually equal to 5x plus 8 when x is 0 and y is 8? Well, let's see. My y is 8, so I'm replacing y with 8. And I'm asking myself, is this actually true? Well, this side of the equation stays 8. 5 times 0 is 0. And so when I'm done, I get 8 equals, well, 0 plus 8 is 8. And is 8 equal to 8? Well, of course it is. So yes, 0, 8 is a solution. How about this one? 4m minus 5n equals 7, and the point's 3, negative 1. Now, how do you know which one's m and which one's n? Well, just think about the alphabet. M comes before n. So I'm plugging this in. 3 for m, so 4 times 3, minus 5 times, and n is negative 1. And I want to know, does this actually equal 7? Well, let's see. 4 times 3 is 12. And then minus 5 times negative 1. That's 5 times negative 1 is negative 5. So minus a negative 5 is going to make this plus 5. Well, what's 12 plus 5? It's 17. 17 equals 7? No. This is a crazy statement, right? 17, of course, is not equal to 7. So, no. 3, negative 1 is not a solution, okay? So to check for a solution, you're just seeing if the equation is actually true when you let the variables be those values, okay? And you notice that when we did have a solution, we got something very, I almost call this a duh statement. It wouldn't be very profound if someone came along and said 8 equals 8. Well, of course it does. And then when we did not have a solution, we got very much a nonsense statement. 17 equals 7. No, that's crazy talk. So logically, right, if we have a solution, that leads us to a true statement. And if we don't have a solution, that leads us to a false statement. Because what we're doing right here, when we plug in 3 and negative 1, we're actually saying, let's pretend that is a solution and see what happens. Well, under the assumption that it was a solution, we got something crazy. So our assumption must have been wrong. So if it is a solution, you get something that's silly but true, like 8 equals 8. And if it's not a solution, you get something crazy, like 17 equals 7. Okay? All right. So our ultimate goal here is to be able to graph. And you might know that to find a line or to graph a line, you really only need 2 points. Well, what do I mean by that? Well, 3, 1, where is that located? 1, 2, 3, 1. And then negative 2, negative 2, negative 4. 1, 2, 3, 4. Now, I can graph a line through these 2 points, right? And so if I do that, let's see, I'm going to be very careful about this. Okay. And we're going to go this way too. All right. Not bad for freehanding on a computer. And so let's check. We want to use the graph to find another solution and verify that it is a solution. So what do I mean by that? Well, we know that this is the point 3, -2, -4. We know that this is the point 3, 1. So what other points do you find on this line? Well, let's be convenient here. How about, I don't know, how about this point right here? That point is, well, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. That's the point 6, 4. And is that a solution to the equation y equals x minus 2? Well, let's check. Y is 4. X is 6. What's 6 minus 2? Oh, it's 4. So 4 equals 4. All of these are solutions. If you look at 3, 1, if you subtract 2 from the x coordinate, do you get the y coordinate? Yeah. If you subtract 2 from -2, do you get -4? Yeah. So what's interesting is that really all the solutions to this equation form a line. The solutions form a line. In other words, every, even the ones that are, not whole number valued, every point on the line is a solution to y equals x minus 2. Okay? All right, how about this one? Find 8 solutions to the equation y equals 2x minus 3. Plot them, and let's see what we notice. So I would like you to pause the video, and I would like you to pick your own 8. Now, I'll give you some direction here. So what I'm going to do is I'm going to plot, whoops. I'm going to be kind of strategic. I'm going to start over here, 1, 2, 3, 4, 5. Might start at, I don't know, -3. And then -2, -1, excuse me, 0, 1, 2, 3, 4, 5. Is that 8 solutions? 1, 2, 3, 4, 5, 6, 7, 8. Ooh, I got 9 solutions. Yeah, let's get rid of the -3. Why not? And then what I'm going to do is just plug in. So to get my y coordinate, come on, -2, or I'm sorry, 2. And then what's my x? -2 minus 3. Two times -2 is -4, minus 3 is -7. And so the point will be -2, 1, 2, 3, 4, 5, 6, -7. Okay? So I want you guys to go ahead and fill this out. Find all the y's that correspond to these x values and then plot the points. Okay? Pause it. Do it. Did you pause it? Are you back? Pause it. All right, so hopefully you're back, and hopefully you've done this on your own. Let's see. -1, -5 is my next point. And then 0, I get -3. When I plug in 1, I get -1. And if you're saying, uh-oh, how are you getting those? Well, get in and pause it. Go back and plug these into 2x minus 3 for yourself and see what you get. When I plug 3 in here, I get 3. When I plug 4 in, I get 5. And when I plug 5 in, I get 7. So 0, -3, 1, -1, 2, 1, 3, 3, 4, 5, and 5, 7. Okay? And what I want you to notice is that when you connect these, they all sit on the same line. So again, that's what I really want to hammer home here, is that a line is the set of all solutions to a linear equation. Every point on this line would satisfy the equation y equals 2x minus 3. Okay? In fact, that's one of the ways you've known you've done it correctly, right? If one of these points had been out here somewhere, then I would say, uh-oh, those are supposed to fit on a line, so I better double check that point, okay? All right. So at this point, you should be able to build a table like this, plot some points, okay? And then construct a line and check for solutions, all right? And when we are going next, or where we're going next, is we're going to start looking at properties of linear equations. Things like, where are the intercepts? How do we measure the steepness? What's that called? And then finally, putting those things together to graph the lines. And in later sections, everyone's favorite, doing some modeling, meaning what are some applications where you might see these linear functions at play. All right, so until then, I will leave you to work some problems.